What do you believe is the most important role of blockchain? The primary function of blockchain is to validate digital data without the use of intermediaries. Then, what is the current state of blockchain? Blockchain technology has been around since its introduction via Bitcoin. But its practical application is centered primarily on token transactions. Such activities include issuing cryptocurrencies, collecting money, trading on cryptocurrency exchanges, DeFi platforms that incentivize token deposits and cryptocurrency holding, and NFTs that digitize items in games and other digital assets. These are the primary use cases of blockchain technology today. So, contrary to predictions, why does blockchain usage dwell only on token transactions? As you may be aware, the first issue is slow performance and limited scalability. Performance is the rate at which transactions are processed, and scalability involves maintaining high performance, even when blockchain usage increases. Untrammeled blockchain functioning is possible due to multiple nodes obtaining consensus, making processing slower than server-client systems. Yet, the current state of blockchain needs to improve its performance, and many popular ledgers need more scalability. The next problem is the method of blockchain validation. As the term implies, validation requires multiple nodes to have the same data. Let us consider the potential issues. Verifying historical data demands all nodes to store the same information, leading to a significant storage burden, especially during peak blockchain usage periods. What's more, it loses the efficiency of traditional server-client systems. Imagine if blockchain replaced the traditional server-client setup in online banking. Financial data stored on a standard DBMS server would need to move to a blockchain, giving rise to new complications. This transition results in slow processes with near impossible usability, and unintended exposure of sensitive information. The structure of blockchain transactions prevent cancellations as well. Due to these issues, the efficiency of using distributed ledgers in online banking becomes highly impractical. As a result, most global IT organizations are skeptical of blockchain, and the current state of blockchain could be more promising. So far, we have addressed why blockchains are limited to token transactions and aren't widely used in banking. Now we will talk about Locus chain, a layer 1 blockchain that can tackle most of these issues. This blockchain is different. Not only does it provide exceptional performance and scalability in a fully decentralized manner, which no other platform has accomplished, but it is also built on a patented technology for data verification, even when nodes have different data. This is the Locus chain architecture. First, it abandons the linear ledger structure in favor of a parallel ledger design, known as account-wise transaction chain, AWTC, in the form of a DAG. This enables efficient transaction processing while using VRF-BFT consensus. On top of that, we address scalability with full dynamic sharding. The problem of nodes requiring identical data storage was solved by drastically downsizing the ledger, by verifiable pruning, and separating the verification and data processing layers. High-performance processing is possible by allowing specifications for token transactions to be processed with core scripts core logic, rather than smart contracts. VME stands for Virtual Machine Engine, which is Locus Chain's smart contract technology. Currently, Locus Chain is designed to support multi-parallel execution verification, not only for the widely used Ethereum virtual machine, but also for new and enhanced virtual machines. Let me explain in more detail. Locus chain is the first to implement BFT deterministic consensus into DAG ledger structure, which has been recognized by patents in Korea, Japan, and Russia. The patent shows the ledger of Locus chain as a parallel DAG structure rather than a straight linear structure. As a result, the bottleneck in transaction recording is removed, and it maintains high performance by obtaining consensus and recording in transaction units for every account, regardless of growing transaction volume. Next is dynamic sharding. With many nodes operating in different parts of the world, responses from nodes with slow network performance will inevitably be late. Slow network replies and growing transaction demands can cause traffic overload between nodes, ultimately slowing blockchain transactions and causing severe issues. Dynamic sharding was developed to address this problem. It enables dividing the network into an increasing number of shards, based on nodes and traffic volume. Nodes are periodically shifted between shards to prevent potential hacker targeting. This allows Locus Chain to process real-world transactions at over 4,000 per second, while using only about 10% of the network capacity based on 100 megabytes per second. There are 8 pending technical patents for dynamic sharding. Moving on to another core patented technology of Locus Chain, verifiable pruning. This innovation not only decreases ledger size significantly, but also separates the verification and data processing layers, removing the need for all nodes to hold the same data. Locus Chain's ledger uses a hierarchical skewed Merkle tree structure by account to accomplish this. Verifiable pruning, as indicated on the slide, provides complete data validation despite variations in data storage among nodes. These developments have 2 major effects. First, the size of each node's ledger is significantly reduced. Even at 4,000 to 100,000 transactions per second, Locus Chain's ledger size remains under 10 gigabytes. Other blockchains would require hundreds of gigabytes of space each day. Verifiable pruning has another major advantage. It overcomes the limit of traditional blockchain verification methods, which need nodes to store the same data. This technology has found practical application in the online game, Kingdom Under Fire: A War of Heroes, currently being serviced through Steam, the world's largest online game platform. It is an entirely blockchain-powered, serverless online game that runs the nodes whenever launched. Each player's history and data are solely stored on the computer running the node, ensuring thorough blockchain verification and protection against any tampering with gamer history or game data. This approach can be expanded to many other P2P online games, and chat, video communication, and conferencing systems outside of P2P online games. It offers blockchain operations without the use of traditional servers. The profound effect of Locus Chain's high performance, processing power, and verifiable pruning technology is that it allows blockchain verifications with existing legacy systems, while maintaining their data storage techniques. In healthcare systems, blockchain verification requires all data to be stored on the blockchain. With Locus Chain, complete verification is possible, even if the data isn't stored on every node. This tech know-how allows legacy systems to maintain their efficiency while benefiting from the objectivity of blockchain verification. Breakthroughs like this elevate the adoption of blockchain technologies, and we believe it will allow blockchains to fulfill their initial role as verification systems in full. This is the ecosystem that Locus Chain will create. Other blockchains have already established themselves in the ecosystem of token transactions. Locus Chain's complete decentralization, high-performance processing, and scalability offer it a competitive edge over other ledgers in the market. In reality, token trading accounts for a small portion of the total IT services domain, less than 1%. Locus Chain's separation of the verification and data processing layers allows it to integrate with widely used DBMS systems from legacy systems, verifying blockchains without requiring complete data storage within Locus Chain. A clear demonstration of this is the data record system of the serverless P2P online game, Kingdom Under Fire: A War of Heroes. This technology allows Locus Chain to venture into other areas of blockchain applicability, beyond just token trading. Essentially, this is the foundation for Web 3 or the worldwide blockchain web, today's widely discussed concepts. The core technology of Web 3 is blockchain. Ultimately, Locus Chain's verifiable pruning technology, which fully separates the verification layer from the data layer, will be the core technology for properly establishing blockchain systems. Locus Chain has many possible applications, including CBDCs and smart cities. Notably, Locus Chain's low resource consumption structure allows nodes to run on smartphones and IoT devices. Locus Chain directs us back to the original purpose of blockchain. Its design separates the verification layer from the data layer. Unlike existing blockchains, this makes validation possible without needing duplicate data on the nodes. It also allows high-performance data validation while utilizing the existing legacy system without data capacity limits. Web 3 is a next-generation Internet model built on an environment where all data on the Internet, whether it's text, images, 3D data, or any other form of data in any capacity, is validated through blockchain to instantly verify the owner, its authenticity, and its change history. Web 3 had remained an idealized dream until now. However, Locus Chain, with both scalability and high performance, has now demonstrated for the first time in the world, that data can be verified, even when the verification layer and the data layer are separated. The result is the only next-generation blockchain that can verify huge amounts of infinitely growing data, and realistically implement Web3. As proof of this, you've publicly seen the updated Locus game chain, where each user's game history data is recorded and processed to be viewed even in a serverless state. This shows that the true Web3 model is actually operational. In the future, today will be remembered as a monumental day in blockchain history. The day the world saw the beginning of the next generation of the Internet, Web3. Thank you.